So hello everyone, welcome to this new session. So in the last classes we have discussed all the curve fittings, all the correlations, but in the correlation concept I have missed one note that is an important one that you need to be knowing it. So I'll say that first and I'm going to start with the new topic today. Okay, so the important note that we are yet to cover is the value of R. This R corresponds to the coefficient of correlation. That is, the value of coefficient of correlation always lies between whatever the values we are going to find for R, right, using the formula. Those values always they lie between -1 and 1. The value of R will not extend after 1 and will not extend before -1. These values strictly lie between -1 and 1. Okay, yeah. So here we have few of the conditions that if R is a perfectly equal to 1, so that we can say that the correlation is perfect positive. Okay, so sometimes in the question they would be giving some of the data, and at the last they would be giving one question that prove that the coefficient of correlation is a perfect positive. So we need to know that whenever the coefficient of correlation is equal to 1, is exactly equal to 1, then we say that the correlation is perfect positive. And the correlation coefficient is, if exactly equal to -1, then we say that correlation is perfect negative. Then if the value of R is when we solve, if we get it as 0, then there is no correlation between the two variables. So whenever R is equal to 0, there is no correlation between the two variables. Okay, yeah, so that's all. So now we are going to start with the concept that we have told that we are going to start, that is regression, the last concept. Yeah, so this is regression analysis, the last topic of this module. So let's discuss in brief about this regression analysis. So this regression analysis is the estimation of the unknown value of one variable from the known value of the other variable generally. Okay, so we have a few lines of regression. That is there are two lines of regression given. That is, the given lines of regression given are y is equal to ax plus b, or we can say that the regression line y on x, and the other line is x is equal to ay plus b, or else we can call it as the regression line of x on y. So here our goal is to find these two regression lines. Okay, y is equal to ax plus b or x is equal to ay plus b. Okay, yeah. So we have certain equations given here. That is, the equation of regression line y on x, that is y is equal to ax plus b, is generally given as y minus y bar is equal to byx b suffix yx into x minus x bar. Okay, and here we know that y bar and x bar corresponds to x bar is given as summation of x by n and y bar is given as summation of y by n. So now you would be wondering, what is this b suffix of yx? So here we have again a formula for that b suffix of ys. We can write it as summation of capital xi yi divided by summation of xi square, where x corresponds to x minus x bar, y minus y bar. Also we have a formula for byx given as n into summation xy small letter xy minus summation x summation y divided by n into summation x square minus summation x the whole square. So by seeing this formula, you would be remembering one formula, that is, we have discussed a formula related to the coefficient of correlation, right? R, right? Coefficient of correlation we have discussed, right? So in that, in the numerator term remains the same, but in the denominator we had square root of this term along with the y term, right? But here, since we need to find the regression or equation of regression line y on x, whenever there is y on x in the denominator part, only the variable x variables would be written. Okay, in order to find the byx. Similarly, we have another equation of regression, that is of x on y, or x equal to ay plus b. So here also it's the reverse of this. So in order to find the equation of regression x on y, we have a formula x minus x bar is equal to b suffix of xy, right now. Okay, Here it was yx, now it is xy. So in order to remember this, you can remember that is equation of regression line. Whenever there is y on x, we have here yx. Whenever it is x on y, we have here xy. In order to make you remember. And here the positions are changed. Here it is x minus x bar. Now here it is y minus y bar. Okay. And other all things remain the same. That is the value of x bar and y bar. And here the value of bxy is given as n into, again the numerator remains the same here, that is of the coefficient of correlation, and the denominator here would be now only the y terms would be remaining, along with the square root sign will be cancelled. Okay. Yeah. So this is all about bxy, and for that this bxy whatever we have calculated, right, that we need to put in the given equation of regression line, that is this one. Okay, for both cases, y on x and x on y. Okay, so now we can see some of the properties of coefficient, that is both the regression coefficient have the same sign. Okay, here, but we have another interesting property, that is by finding these regression lines, we can also calculate the coefficient of correlation. Okay, is the geometric, then this coefficient of correlation r is the geometric mean of the regression coefficients. Okay, so we can write it as this coefficient of correlation r corresponds to plus or minus square root of byx into bxy. Okay, this is in some of the problems they would be asking, along with the regression lines, calculate the coefficient of correlation. So in order to calculate the coefficient of correlation, don't need to write again the formula of the coefficient of correlation and calculate. Besides that, whatever we have founded, right, that is the byx and bxy, when we have calculated the equation for regression of y on x and x on y, that only byx and bxy substitute in this formula and write it as r is equal to plus or minus square root of byx into bxy. So this plus or minus is just for the namesake. Most of the times this minus won't be there. Most of the time when solving the problems, we can directly write it as byx into b suffix xy. Okay, this is suffix yx. Okay, yeah. So this was all. So if both bxy and byx are positive, then we take r, the coefficient correlation, as positive. If both are negative, then r also would be negative. So given two regression lines, we can also determine as x bar, y bar and r bar. Yeah. So this was all about the deep concept about this regression. Okay. So now we are going to discuss few problems so that you will be clear about the concept. So this goes your question of the regression lines. So the question would be like this: find two regression lines for the following data. Okay, where the data is given for x and y. Here are the given observations. So here the number of observations again are 1, 2, 3, 4, 5, 6. Right? Write it as 6 here. So now in order to find the regression lines, the parameters we need to be remembering is x, y, x square, y square and xy. Okay. These are the 5 parameters. For that we need to put the tabular column. For all these regression line sums, these are the general parameters. Okay, yeah. And also we have x bar and y bar, because in the equation of regression lines we have these terms x bar and y bar, right? Yeah. Though that also we need to find it and keep. Okay, yeah. So now write the tabular column. Write the values of x, y. Substitute, take its summation, since summation of x is required to calculate x bar, right? And also summation of y is required to calculate y bar, right? Yeah. So we need to take the summation of x and y also in this case. So x square, that is take the square of all each x terms and sum it up. So here the summation of x, first we get it as 21, here we get it as 79. Summation of x square, we got it here as 91. Summation of y square, we got it here as 1057, and summation of x into y, we got it as 272. So now calculate x bar and y bar. The formula for x bar is summation x by n, where summation x is given as 21. So 21 by number of observations is 6. So 21 by 6 is equal to 3.5, and summation of y, similarly summation of y is given as 79 divided by the number of observations as 6. So 79 by 6 would be 13.167. Okay, we got here x bar and y bar. So now we need to find the equation of regression lines, that is Yeah, they have given to find two regression lines there. So we have only two regression lines in general also, that is one is for y on x and x on y. Okay, so for first to find equation of regression y on x, this is our general formula, that is y minus y bar is equal to b suffix yx into x minus x bar. So first we need to find b by x. Okay, so in order to find the b by x, this is the formula. If you compare to correlation coefficient, the numerator remains the same, and in the denominator the square root get cancelled and only the x terms would be there. Only the x terms would be there in order to calculate the equation of regression y on x. And similarly for x on y, and the denominator term, numerator remains the same, and the denominator square root goes, and only the y terms would be there. Okay, so now write the formula. This is the formula. Here summation x y is given as 272. Substitute it. Summation x, summation y is given as 21 and 79 divided by n into summation x square, that is 91. So 6 into 91 minus summation x the whole square, that is 21 square. So after solving this, we get it as b by x, b suffix yx, we get it as minus 0.257. So whatever we got it, put it in this equation. So now our equation would be looking like, write this y as it is. Since our goal is to get the equation of regression y on x, that right? So that is given as y is equal to ax plus b, right? This is our general equation of regression y on x, right? So we are here a, y and x, we need to keep it as it is in this equation. Okay, yeah. So y minus y bar, what we have got, y bar 13.167, right? Substitute that, 13.167 is equal to b by x, we got it as minus 0.257 into x minus x bar is 3.5. So now here in generally we have y in one side, right? So bring the y in one side, rest all the terms in one side, that is bring this y to one side. So this would be y equal to, so this minus 13.1367, if you bring it to this side, it would be positive. So it would be 13.167 minus, multiply 0.257 into x first, plus, so minus into minus is plus, so 0.257 into 3.5 would give you 0.8995. So now again simplify this, 13.167 plus 0.8995 would give you 14.0665 minus this term, that is 0.257x. So this is your equation of regression y on x. Similarly find it for x on y. So here the formula is x minus x bar equal to bxy into y minus y bar. Find a b suffix xy by putting the formula, we get it as minus 0.267 now, and again put this bxy in this formula, that is x minus x bar is 3.5, bxy is minus 0.267 into y minus y bar is 13.167, and bring x to one side, since the general is formula is given as x equal to ay plus b, right, for the equation of regression x on y. So yeah, bring one x to one side and rest all the terms to other side. So this minus 3.5, when it goes to other side, it would be plus 3.5. And now while solving this, we get our equation of regression x on y. So here we got the two regression lines, that is y equal to ax plus b and x equal to ay plus b. Okay, yeah. So this is the way we need to solve this problem. So we have one more problem where we need to find the correlation coefficient, okay, using the equation of regressions. So yeah, we will discuss that also now. Yeah, so this is the very important question, okay. The given question is, the following table uses the height of the father x and the height of son y. Okay, so here the father is represented as x and son is represented as y, and they have given the heights of the different fathers and sons, that is x and y. So here we can see that the number of observations are 1, 2, 3, 4, 5, 6, 7, 8. So we can write it as n equal to 8, right? And after that, so in order to find the regression, we have the parameters x, y, x square, y square, x, y. Okay, substitute the values of x here, y here. So here I got the summation of x as 544. Similarly, summation of y as 552. X square means we need to take 65 square, 66 square and write all the square terms. And I have got the summation as 37028. Similarly, summation of y square, I got it as 38132. Similarly, summation of xy I have got it as 37560. These all the things you need to do using the calculator, and you need to be very careful while typing the numbers. Okay, so this takes a lot of time, but you need to be very quick in this putting the values and writing it in the tabular columns. Okay, this takes a long, very much time this takes. Okay, you need to be very quick. Okay, yeah. So again, in order to calculate x bar and y bar, the formula is summation x by n, summation y by n. Summation x I got it as 544. Substitute that 544 by the number of observations are 8. 544 by 8 I'll get it as 68. Similarly, 552 by 8 I'll get it as 69. So now again the same thing, calculate the equation of regression lines y on x and x on y, and y on x is given as y minus y bar, b by x, x minus x bar. Calculate b by x. This is the formula. Again, whatever we have got the value, substitute that. Okay, and find b by x first. What if b by x? I will get it as, by simplifying this, I will get it as 0.66, and now put that 0.66 in this equation, that is y minus y bar I got it as 69 equal to b suffix yx I got it as 0.66 into x minus x bar is again 68. So bring y to one side, and we got the one regression line y on x, that is y equal to ax plus b. Similarly, equation of regression x on y, right? X minus x bar equal to b suffix xy y minus y bar. Find b suffix xy using the formula. I got it as 0.545 by simplification, and put this b suffix xy in this formula. So while putting in the formula, I get it as bring one x to another side. So this is x equal to ay plus b, that is regression line on x on y. So I got it as 0.5445i plus 30.395. Okay, so these are the two lines of regression, but they have told to calculate. See, in the question they have told to find the lines of regression and hence calculate the coefficient of correlation, right? So we have discussed that the coefficient of correlation, whenever they have given the two regression lines, are some square root of b suffix yx into b suffix xy. So when we were finding the regression lines, we have written the values for byx and bxy, right? So those values only we are going to substitute, that is byx is 0.66 and bxy is 0.545. Put those values in this and find the correlation coefficient. So this is equal to 0.5997. Also we can write it in an approximation way, and we can write it as 0.6. Okay. Yeah. So this was the problem related to the coefficient correlation. So we have one more problem, that's a very important problem. So yeah, I am going to bring that question to you now. Okay, so this goes your last question. Okay, so listen to this very carefully, since this is a very important question and it is a sure question. I'll write it here. Sure question. Okay, this might come, so please take a good look on this question. So here the question goes like this. So in a partially destroyed laboratory record, only the lines of regression of y on x and x on y are available. Here the lines of regression are given as these are not actually the lines of regression, they have given two equations. Okay, so we need to convert it to the lines of regression. Okay, the lines of regression are available as 4x minus 5y plus 33 equal to 0, and this is the regression line y on x. Okay, and 20x minus 9y equal to 107 respectively. So now we need to calculate the coefficient of correlation between these two regression lines, and also we need to calculate x bar comma y bar. Okay, so here for this x bar comma y bar, we need summation x summation y, right? That is all. For that we need to make all the tabular columns and all. So we have a shortcut to find x bar and y bar here, that I am going to tell you. So first write the given, that is regression line y on x, that is 4x minus 5y plus 33 equal to 0, right? But the general regression line y on x is given as y is equal to ax plus b, right? This is the general regression line formula. But here the equation is given like this. So what we need to do is, this equation we need to bring to this form, okay? For that we need to do a sum of the substitutions, that is we need to place some of the terms in one side. So here y is in one side, right? So in this, do the same thing, this 5y is there, right? Bring this to one side and bring all other terms to other side. That is, if we bring this 5y to other side, here we have 0, so this would be plus 5y along with 4x plus 33. So y is equal to 4x plus 33 upon 5, right? So now split this denominator like y is equal to 4x by 5 plus 33 by 5. So here this is of the form y is equal to ax plus b, right? So where the value of a here is 4 by 5 and the value of b here is 33 by 5, okay? But here, in order to write the coefficient of this regression line, that is b by x, we can directly write it as, we can directly take the coefficient of x in this equation, that is the coefficient of here x is 4 by 5, right? That only becomes your value of b by x, okay? Yeah. So in this way we need to solve this. So similarly take the regression line x on y, that is given as 20x minus 9y equal to 107, but generally it is given as x equal to ay plus b, right? So bring it to this form. For that x is in one side, right? So this 20x term, bring it to one side. So if you bring this 9y to other side, it should be plus 9y, 107 plus 9y, so x would be 107 plus 9y upon 20. So split this denominator, it would be 107 upon 20 plus 9y upon 20. So in order to find bxy, we need to consider the coefficient of y here again, that is 9 by 20. So from this we got byx and bxy. So now we can find the correlation of coefficient, that is r equal to square root of bxy into byx. Substitute that 4 by 5, 9 upon 20, and by simplifying it, the answer we get it as 0.6. But also we have few more terms to find, that is we need to find x bar and y bar, right? So we can directly find x bar and y bar by the given two equations are given like this, right? So we can simplify these two equations and we can find the values for x and y respectively, okay? So that is again the simple mathematical things that we have studied in the lower classes, or else you can put it in a calculator as well, okay? So again, mode, equation, and it's of the form a n x b n y plus c n, right? Yeah, so press 1 and again fill the coefficients, that is the first coefficient here is 4, minus 5, minus 33, right? And in the second line it is 20, press equal to, minus 9 and 107. See, here we got the value of x as 13 and y as 17. So these itself are your x bar and y bar, okay? This is a shortcut method. So whenever in these type of questions, when they ask to find the values of x bar and y bar, you can directly write it as x bar is equal to whatever we got the value of x by solving for these two equations, that is 13, and whatever we got the value of y, that is 17. So in this way you need to solve this question. Yeah, so that's all for this session. So in the next session we have a few more important questions to be one question to be discussed. Only one question along with one small concept. Okay. Yeah, so that's all for this session. Thank you.